Okay, test. 1, 2, 3, test. Okay, so I am live. I just need my camera to work. Okay, and that's it. Oops. How to do that? Oh. All right. Okay, it should be working now. Let me take a look. All right, so that's fine. Okay. So I'm gonna start from where I left off. So we had we did a basic setup with GLFW. We created a window, made the context current, and we got a triangle drawing on the screen. I left last time and I encountered a bug. Couldn't solve it for like 40 minutes. And then we were also... Yeah, I'm back now. Yeah, I'm back now. All right. Ah. Anyway, we did this basic boring setup before. It didn't really do much, but there's like a couple bugs with the program, and yeah, so we were implementing the camera. I don't really like this music. We were implementing the camera, trying to research what we needed to be able to include the camera, and I kind of just want one math header. So I'm just going to call it vector math N1, and then I'm going to grab, actually before that, I realized last time I wasn't using a debugger when I really should have been using a debugger, because that bug would have been a lot easier to find if I had a debugger. So I did some research and learned how to set it up for VS Code, because I did not have that. So we need a launch.json, and then I just copy and paste my prefigured configured thing. So now if I add a breakpoint, I think we can debug the program. F5. Continue. Yeah, so we can debug now. You can see all of these file stuffs, what the VBO value is, because right now they're not initialized, their default, and that will be useful because we can look at return values and hopefully figure out what was wrong with the program last time. So Anyways, despite using a debugger, I will continue now organizing the math library into a vector math. And I'm also going to put it into a namespace because combining everything into one, it would be nice to organize into a namespace. So sort of STD, we can maybe think of something like something, I'll just call it vecmath. And then we will put all of the classes in this namespace. And then so we need this one. And then we need this one. All right, and we can go ahead and delete these two. And then lastly, we just need to update our includes. And oh man. I've got to preface all of these with the new namespace I've just made. This is where the bug was happening, which we'll be dealing with really soon. After I just fix these vectors that I've been doing with my new vec math. Actually, we really could have done that, but right. And then we just need to change this include up here. So now we don't need 3 includes, we just need 1, which is nice. Back to math. Right, we'll try compile. Okay. We are getting some errors already. Back to debugging. Oh man. Okay. Okay, we're gonna have to include our math. Wait, no we don't. So in vectormath.hpp on line 33 here, cout is not a member of std. Hold on a second, am I now experiencing problems? Oh, I haven't included IOStream. That was weird. Alright, we've also got camera vector 3 uses camera, which is the one being defined. That's in our camera file. Oh man. Right. That should be prefaced there. Missed that one. What else? Right, so we've got camera.cpp, line 3, cannot include file. Yeah, because it doesn't exist anymore. Okay. Okay, now we should compile. Oh. Okay, we're compiling now. Right, that's good that we are now compiling. Right, so next up on the to-do is finding the bug. So basically the bug last time where I left off was that when we were scaling with our matrix class, I had defined the scale function. It was using this buffer here as the underlying to do the scaling, even though I was copying, and I went away, did some research on references, and now we are going to try to debug this. So first things first, what's going on here? That's fine. So first things first, I want to put a breakpoint here on this line and on this line, and let's run our debugger, see if we can figure out what's... Oh, that was the window. Okay, I was like, whoa. Right, so we're gonna step into this function call. All right, let's see what we've got here. So we've got the buffer, which is what I'm passing as a pointer, no problem. Step into, I did not want to step into that. So we step out and let's step over. All right, so we've got buff, which is, for some reason, honestly, I'm not really sure what the meaning of that is, but I assume this is the memory address which the pointer is pointing to. Maybe that would change when I... Okay, and then we've got copy. Has a value of 205 right now, but it hasn't run yet. Next, so first things first, I think I want that to... Okay, so yeah, it gets a value of 1, which is good. Copy is 1. Copy is a local variable. That's how I now know it's not doing any nonsense with references. Okay, and then I step over. I update my buffer. And you can see here now all the values in our buffer, which is our vector of floats. And we've now assigned 1 as the first, which is what I want. And it doesn't look like there is any manipulation there going on. So seems like the buffer is being written correctly. I'm just going to keep the same breakpoints, change a value, and then re-debug. So step into this, step over, step over. Okay, and I'm going to run this for loop a couple of times just to look at the values inside the vector. So we should now have 2. Okay. I didn't recompile the program, so my changes were not reflected. Okay, for some reason got that open. Let's go ahead and re-debug this. Continue to the first breakpoint, step into this. Okay, step over a couple times. Right, now this should have 2 in it. Okay, it does. Okay, great. So I'm completely happy that we are copying the value over. No worries, right, great. Oh man. Let me set a breakpoint here and then continue. So then we are entire this. We got this. We got an allocator. Yeah, fine. Okay. That should just mutate. Oh man. Buffer. Let's go back to buffer, which is still in memory, which is fine. And let's then take a look at, that's the string buffer. We got mat, program, all of these variables. I'm looking for buff is there still. Good. And buffer. Oh, buffer. We got the raw view. For some reason, string buffer honestly Don't know why it's a string buffer. That is. Oh, this is Hey, look, you can see my file. This is a different. Wrong. What am I looking for? I'm looking for Matt. Oh, yeah, I'm looking for Matt. Okay, this is good. So now I know it's got these values in it. Model location is still undefined. Program is set to 3. What? Why? Shouldn't program be 1? Huh? Alright, I think that's really weird. Let me take a look at the bug now. So the bug was that when I was scaling and then uploading to model, the underlying pointer to the buffer of Matt. This is mutating the array. This is uploading the data. We're just gonna check something. If I just do Matt.getBuff here, and then just for the sake of it, print out the pointers so that I know the compiler doesn't do any sort of nonsense with optimizing. Okay, and now I just need to recompile. And I need to start debugging. Continue. I just continue. All right. Continue. All right, now I want to take a look at what's inside buff pointer and compare it to buff, right? Because if these pointers are the same, if mat.getBuff is for some reason returning this buffer, which is the behavior which it looked like it was doing, then I know that I've got a bug there which I need to fix. But we can see buff pointer is not the same as buff over here and here, which means that we are not pointing to the same array, which is good. This is what I needed to see, that we're not pointing to the same array. The values in buff have now been all scaled by 5, which is what I wanted. So this begs the question, okay, buff pointer is pointing to is 20. The memory address is not the same as this memory address, so we are fine there. But hang on, little weird here that buff is being represented as, no, it's just because I defined it like that. Actually, this would be better if I take the float star compare buff pointer equals buff, just like this. Hopefully this degrades into a pointer, then just copies it over. This is what I really want. I'll keep this one breakpoint, and then I'm gonna recompile and see what happens. And hopefully I can fix this bug so that I can continue with the setting up the camera. I've already just compiled it, haven't I? So let's go ahead and Do this. Okay, whatever. Go next. All right. Now we're gonna compare these buff pointer and buff. Okay, they're different. Compare buff PTR. Compare buff PTR. 399. 399. Great. All right. I'm happy that that's not the problem now. So everything is fine with this. So the answer to why is this here. Watch, I'll show you guys what I mean. So you see this is scaled like this, right? Now watch, if I change this to 3, tell me if you think this gets wider or not. Didn't get wider, right? It's the exact same. So then you ask, okay, so why is it the exact same? And the answer has just got to be, I don't want to just say that, you know, the answer is this, because clearly I don't know. If I knew, I would be fixing it already. But take a look at vector math, and for our matrix, where here, this is what we're doing. We're calling this constructor like we showed, and I was happy that it was copying the values. So the constructor has no problem. We know get buff is returning a pointer. However, that's what the issue was potentially, is that if there is a change between when we call mat.getBuff and the actual matrix we created, then there might be a reallocation, and the pointer, underlying pointer to it might be no good. So mat.getBuff, instead of returning buffer.data, what if we get a pointer to the first element or a reference or whatever, typecast the reference from the first element, so that we can, instead of returning this, just return a pointer to the first element, because that's kind of like the same thing there. Okay, let's see if this fixes the problem. I don't what? I mean, this is returning a reference, right? I'm trying to get pointer here to this reference, but what if this conversion is not working? So I will split it into 2 steps, where we take the floats like this, and then we just get the memory address of the reference itself. Like memory address of, well, this should work. I kind of need more screen, more reading here. So we're trying to convert const type to a float type, which is happening on line 35. No problem, const. Okay, I think that's working now. Wait, is that working? I don't want to get excited. I do not want to get excited. Oh. Oh my goodness, I just realized what's happening. OpenGL has got the perspective division step where it divides by W. I'm scaling even W which means that all of my scaling just gets undone. The triangle looks like it's not working, and when I make local changes here, it reflects and it makes me think that everything's working fine. So the problem is that it had nothing to do with the way I was assigning, whatever this redundant thing I'm doing here. And it didn't even have a problem with the get buffer function. Returning .data was fine. The entire problem was with the OpenGL pipeline returning this. So as a result, I think what I'll do is in my scale function, I will get the last element, the W component, which is the last element. I think it's always the last element, even in a transpose matrix. So row column major and row major, I believe that 15th element in the array is the same. So we will scale that, divide that. And if I divide that by float, this will be fine. Or in my scale function, I can elaborate here. this is better, huh? Here, I fix this problem by saying if I modulo 15 equals 0, if not. Hang on, if I could have just done this not equals like this, then do this, but this has a problem when I equals 0 because we see a hold true, so let's say or I equals 0. Let's take a look now if this fixes. Modulo not valid as left operand, type float. Okay, yeah, good point. Good point. Sorry, I thought I was an index, but it's actually the value. So because I want indexes in this case, I'm not going to be using standard for each. I'm going to be using a normal for loop. So let's go ahead and do that. You know that we can just hard code this I less than 16. So now we know that if I not equal to 6, this is much easier. Not I meant 15 here. I mean, it's not really much easier, right? Because we're gonna have to access this, but it is definitely more descriptive. So, and also I learned last time to use @ so that we throw exceptions instead of using I. Otherwise, we get this undescriptive runtime error. Times our scalar. This way, now we're not timesing the W component, which is exactly what we need because perspective division, like I already said, we're dividing by W. Causes massive problems. Yeah, right? Because you take 3 times by matrix, whatever, you get this matrix times by the vector. That one gets scaled up to 3. Everything else gets scaled to 3. So, and then it all divides by 3, so everything stays the same. So there were some warnings here. I actually kind of want to fix them. Oh, this should be times equals. I thought we were just ignoring the reference, which is why it's saying result of expression not used. Okay, and we got this fat thing, which looked funny. Now, if I do this, we should be working, we should be scaling. Okay, we fixed that problem. Let's just double check. Let's try to increase that size by twice what we just saw. Sorry, twice what that looks like. I really want it to work. Okay, it didn't work. That begs the question, am I If I is not equal to 15. Wait, in the scale you only want... What am I doing? In the scale you only want the 3 to be scaled. So why don't I just... I don't really want to hardcode it. Honestly, for the sake of it, let's just actually take a look at what this code is doing. So we will run, let's remove our breakpoints here. Because I put a breakpoint in, I think we'll be fine if I just continue. And it gets us here. Great. Okay. Then we got this buffer here, whatever, cool. Okay, so time scaler, everything, scaler was 10. So we should see everything but this 15 here be 10. Quite clear that that's what's happening. I'll set a breakpoint at this point. At this point. Continue. Okay, and 10. What's going on? All right, we're just because the breakpoints are the same in the for loop, which is actually a little irritating. I don't want the for loop there. Okay, so continue now. 10, 10, 10. Okay, so now this is left. This is just 1. This is what I wanted. I know that's working how I thought it was working. Okay. And then that should be it, right? This should now... How long have I spent working on this problem? 30 minutes. It's a little bad. Anyway, that should now be working. Could it be... Could it be the depth information? Shouldn't be. Yeah, anyway, so... let me put a breakpoint just over here. Let's take a look at what's inside now. Buffer. No, wrong one. What we're looking for is mat, which has a buffer 10, 10, 10, 1. And mat.getBuff. We're looking for buff pointer. Okay, we know that these two are the same. Buffer is the same as buff. No, it's not. All right. So she's a pointer to the first value. That's all it knows. Let's take a look at this function, GeoUniform mat. Okay, because what we want is to check this value. For the vector and matrix command, specifies pointer to an array of count values. Count values. Count values. 1. Should that not be 16? I always thought count. Oh no, yeah, so it does. It's the number of matrices that are to be modified. 1 if it's not an array, and it's just not, it's not an array, it's just 1. So specified pointer to an array of count values. Wait, location count, transpose, v0. Yeah, so we have to take a look at the number 4 indicates 4 by 4, i.e. 16 values. Count argument indicates the number of matrices. Yes. Okay, I'm confident we're using this function right. I wonder if the changes will update on the screen. Actually, wait, where's my graphics window showing? It's not showing on any of my monitors. So let's actually see. So is the window open or there behind here? But you see, it's not. This is interesting, right? Because it's not it's not running, but we should see this change when we call GL clear color. The color of this should change actually. Just interesting. Okay, it did not change because you need to swap the buffers. It's actually really interesting to see. Ready? When it swaps, it should change. Oh, it did not change, huh? Oh, there we go. It seems like it was only when poll events got hit, huh? But at the same time, the color hasn't changed yet, so it seems like we've drawn a triangle, but the color hasn't changed when the color updates. There you go, the color finally updated. I don't know why it took 2 frames. Actually, interesting question. But yeah, I don't really know why it took 2 frames. Okay. Right. Still have not fixed this problem. What am I setting for the in my vertex shader? 1, and then we're scaling. Yeah, so honestly, I don't want to be stuck on this problem again with no solution. But I will be honest, that scale does look smaller than... See, changing the scale right now has no effect, and there's a reason for it, related... Couldn't be related to the Z bubble, could it? So I don't need depth information. So if I change this to 2, it gets twice as fat. Wait. Wait. I'm gonna throw this in here. No, I know this won't really change anything. But yeah. What a location, unidentified. Re-identified. Undeclared identifier, sorry. Define it in this scope. Not really sure it's here because I accidentally did that. Yeah, so that's what the normal triangle looks like. Yeah, not really the happiest with the fact that my scaling is not working. Yeah, what could it be? What could it be? Maybe, no, because you don't need... I'm really not happy that I still can't get it to work. I I guess we can move on without, while leaving that unfixed. So, I'll be right back. All right, I'm back. Yeah, I don't know why this bug is not working. I mean, it really sucks because like I feel like I've done everything. I could have done. Like I've accounted for the W component division, like by not scaling it. Yeah, I don't even need to look that up. Right, so next up, just because I'm getting tired of not making progress, is let's just work on the camera class. So we've got position, float, whatever, up, right, near, and I'm actually going to do a derivation. So float near, float far. Not near, yeah, so these are going to be my near and far planes. Then I'm going to have left, float, left, like the left projection of the projection left. Oh, projection right, and then top and bottom. And I'll show you why in a second. This will be really good if this works. Okay, so anyway, that's all done. Right. So before I do the the view matrix, I am going to implement the perspective projection. And here is my explanation of perspective projection, just in case I might turn this into a YouTube video. I don't know. So anyway, the premise of perspective projection, if I just look for something, is that you've got this view frustum. This is a view frustum, like I actually just made it. I don't know if you can tell because of the lighting, but this is basically the camera object, and it's a truncated pyramid. So this is the shape. It looks like this, and then there's one that goes behind it, and then it's got this to go down, to go across, and then behind it, and then like this. And it looks like this. You can see why I described it as a truncated pyramid, because it, for some reason, yeah, okay, that's fine. This is where the camera sits, right? And the camera will actually sit in our world, and by convention here, this is our world. These are the axes in our world. It will sit looking down the z-axis. So here is our z-axis, and this is our camera object. Let's fill this camera out to be black. Anyway, it's looking down there, right? Ah, nice. All right. And anyway, we've got this. This is it's a geometry, right? And we basically take it. Imagine you have it. It's like right in front of you, and then you like take something sharp and you cut it here. Like cut that part of the shape off. Okay, great. What are you left with? You're left with this part of the shape, which if I copy it, paste it beneath, extend this line down, and then just follow these lines as best as I can back. There you go. And this one. You are left with this 2D plane there, which looks something like this if it was to face us. So it would look something like this if it were to face us. Now this plane is actually defined by some variables, right? So we know we're looking down here, down that z-axis, and the distance from this center point in the world, 0, 0, 0, to the point where the center of the like this line will intersect this plane right in the center. So kind of imagine it like this, I guess. It's something like this. That line is like not diagonal. It looks like that. But this line is going through the middle. So that if I draw out this shape again, sorry if this is like a bit long. It looks something like this. Anyway, OpenGL then goes ahead and this is the shape. We've got to map this shape defined in the OpenGL spec by to a shape that is a cube, right? We have got to map it to a cube. So that is literally the problem. The problem is, how do you map this truncated pyramid shape to a cube? There you go. So how do you get from this shape here to this shape there, that shape there? Well, that's what we're going to be looking into. So this range is -1. No, -1 now. As you can see, like that plane there will also need to be mapped into this here. The OpenGL spec defines this to be -1, 1, -1, 1, -1, 1, and anything outside of that range after mapping from these coordinates to these coordinates will be completely culled or like clipped. I mix those terms kind of like informally, but clipped. So we will start by considering, first of all, if we have some point that is lying on the inside here, somewhere in this frustum, and we extract that point back to here. The question is, what is the projected coordinates on this plane, on this screen here, this one? What are the projected coordinates from tracing that back to the camera? Well, we know what do we know about the point? We know that, first of all, let's take a look at this from a different perspective, considering it only in one plane. So I'll now draw a two-dimensional flat image of it. So here is the two-dimensional flat image. This is the plane, and if you remember, I said like it goes through the center. Anyway, our point is here. A camera is chilling over here, and yeah, we just have to extrapolate this back to the camera's origin. Okay, and what do you see? Well, you see that we got two triangles here. One triangle, this one, and this larger triangle, which is made up of just scaling this triangle along there. So there is some factor here where this is scaled, this is scaled. And what is that factor? It's the opposite side over the adjacent. This ratio, O over A, will stay the same because the angle made by this line connecting this point to here is the same for both triangles. So this is our Z coordinate. This can be X or Z. Anyways, before considering angles, let's just take a look at the maths. So I remember if I said that this will project out along this coordinate axis to intersect with this plane, and this is actually called the near distance. So I will call that part n, or near, just near because it's thing. So we know this distance, we're defining this distance. I'm defining this in my code here, float near, right? And then we don't know this we actually do know this distance, sorry, because this is just some point in our world which is from eye space, right? The projection matrix happens after the camera's like the view matrix takes effect, and then at that point the coordinates are in eye space. So we know that this is the point XE, ZE, and then we know that this gets mapped to some other coordinates, XP, ZP. But if you look, what is ZP? ZP is near, right? Because we're mapping everything to this near distance on this plane. Copy this. We do the same from the top below, top down. This becomes Y. And then we can write an equation, okay? So if we remember the opposite side, which is XE over ZE, is the same as XP over near. So we can write our equation. So XP, it's actually kind of a little annoying to write on this, but opposite side XP over near is the same ratio as XE over ZP. ZE, sorry. Like this. Right, this lets us find a equation in terms of the I coordinates XE and ZE using all these three here. So because we now know that XP is going to equal XP will equal near times this. See? Okay. And we know near because we define it. And we know XE and ZE because that is the current state after multiplying by model and view. Right? There you go. These are brackets. Okay. And then we get the same equation for YP, right? But just in terms of Y. For any point XE yp or xe, ye, ze. We can do these two projections, basically taking 3D coordinates and projecting it onto a 2D plane at the distance near from our camera. Okay, nice. So we know this, right? So what's the next step? Well, we know what near is. And let's see. Let's take a look at this plane, because now that we know how to project it, we need to consider this mapping problem here that we had defined earlier. We know this is the mapping problem that we have to map, and we know that these go from -1 to 1 on all axes, else be clipped on all three axes. Consider this, for example, to be x, this to be y, this to be z. Then we need to now map these projected coordinates, whatever they are, defined by the what we wrote here for near. I haven't actually written it yet, it seems, but we need to map this defined plane, which is bordered by some coordinates, whatever coordinates they are. This will be the left x coordinate, the right x coordinate, the top y coordinate, the bottom y coordinate, obviously as pairs. So let me pull this up. So this is the plane which we are projecting on, and these are the equations to project onto this plane. This is the left, this is the coordinate left bottom. This is the coordinate right bottom. This is the coordinate top, right top. And then we are just defining this, like it doesn't matter. We are choosing how to define this plane. So this is not OpenGL defined, but what is OpenGL defined is just this mapping from -1 to 1. So we have to convert from this left top, right top, left bottom into the range -1 to 1. And how can we do that? Well, we need a function which is going to take us from these projection coordinates xp or yp that maps us onto the range -1 to 1, right? So we can consider this to be like a linear mapping, and I'll show you why, because just not as a formal proof, but as a geographical intuition. Because consider this case here where we have one up here, then -1 over here, and then we've got this. Let this be left, because now, and then let this be right. Right, let's say that some coordinate here, right, this part here. Actually, that's a bit too even. Let's say that we are like here, like this. And then there's another coordinate on the plane. On this, sorry, not on the plane, but here. And you can see that at the point, right, if we are doing this projection according to OpenGL by getting the mapping of -1 lined up like this here, because when we want to map our boundaries left and right, left to -1, we want to map the boundary right to 1. And then there is like depending on what our right and left are, these will move and these will move, changing the gradient of our line. Because it's changing the gradient of our line, it's changing this y-intercept. But you can see that we can sort of make right just graphically as small as possible, and while still hitting this. In this case, I don't know if that is valid. But yeah, we're basically looking for a function that maps our x projected coordinate to the range -1 to 1. So we can write this example linear equation with some gradient here. We'll call the gradient A. And this will be times by xp because we're modeling it as a linear equation. And then plus our y-intercept, we don't know what that is. It could be just like 0. It could be something else. No way to know. Okay, so then we need to take a look. We know that we're mapping left to be -1 when xp equals left. F of xp equals -1, and then the same for right, but obviously, not obviously, but right will map to 1. Like this, and then that's there. Okay, so we can use these known facts that we're mapping this one. This value is 1 when xp is right, to write out two equations. 1 equals a times right plus b, -1 equals a times left plus b, same y-intercept. And then you look and you say, okay, so what's a? What's our gradient? Well, looking back to the linear relationship, because we're looking for the linear mapping between these two numbers, which is looking for a linear mapping between these two numbers. We know that this was, say, 1, this was -1, and then this was left. This was right. What is the gradient? In this case, the gradient is change in y over change in x, which happens to be 2 over x right minus left. So 2 over right minus left. So that's our gradient written there. So that's what we know a is. And then using this fact that we know that this is equal to a, we can plug this in to find b, to find an equation for b. It doesn't matter which one, both are right. Anyway, you get an equation for b, which initially is 1 minus, I'm just doing this in my head right now, so 1 minus 2 right over right minus left equals b. I plugged that into this first equation on the top here, 1 equals a right plus b, and then rearranged for b. And then if we can rewrite 1 as right minus left over right minus left. So I'll just copy this like this. And then we can rewrite this part of the equation. And let me just take this part off. Then like this, extend this, and then copy this, and then paste that there. And then put our minus sign. And then simplify this part. And remove that minus because that was just an artifact which mapped this was, that's the same minus. And then we can combine these two. Well, you get minus right minus left over this is equal to b, and that's the equation for our y-intercept. So what do we have as the final equation for the mapping after solving a and b for this function here, which maps the boundary left to right onto -1 to 1 for -1 equals left, right 1 equals right? Well, we get the following equation, which is this, but then we fill out a, and a was here. We wrote it to be 2 over right minus left. So copy this, paste this over here. 2 over right minus left, like that. Then I'm just going to extend this out. Pull that in there. Plus b, and we found b here. So this is our equation. And now if we simply look at the matrix, the projection matrix, which we're multiplying by, maybe actually just before that. So now we've got a function xp, which takes the projected coordinate. But if you see here, the projected coordinates over here actually is coming from these I coordinates over here. So we want to define a function that takes us from xe onto xp, right? What is that function? We did that. We defined that function that takes f of xe onto xp here. Just doesn't really look like it in this representation. We can rewrite this as f of xe equals right. They now just express it as a function. Disconnected, reconnected. Okay, I'm back. So I was just continuing from these two facts that I have here that, yeah. Oh, sorry. I was just continuing from this fact here that we've got xp equals xe times near over ze, and this here. Now, for the sake of it, because we know xp is equal to xe times near, why don't we just do a quick experiment? As we know these two are equivalent, we can get directly a function f that takes an xe. We can just directly get a function that takes an xe by substituting this in here, right? Because this is expressed in xe, but the problem is here that we've got ze, right? So I don't want to do that. Because it wouldn't really make sense to be doing that. Then we'd have a two-dimensional function with more than one argument, which is not what I'm looking for. So yeah, I'm quite close here. I don't really know. I'm just trying to piece this last piece together. So if we consider it, what we've really got when we're doing the multiplication inside the vector is you've got this four-dimensional homogeneous vector xe, ye, ze, and e just means an I space, and we, right? This four-dimensional homogeneous vector, and we are basically mapping from these in multiplication with some matrix, right? Now, for the sake of it, consider this first row to be A, B, C, and D. Now we want, when we do matrix multiplication here, we get the following equation. We'll get the fact that we'll get x in projected is equal to a xe plus b ye plus c ze plus d we. Now we've got to think about this. Which ones can we really use? Well, we shouldn't involve the y coordinate, because in this projection we're not considering y when looking at x. It's just a mapping between projecting onto this plane here. It only considers x, not y. So we know that we want to, at least in this stage, have b set to 0, which means that we can narrow it down. We also know that we're leaving we as 1 for now to save in the for the homogeneous divide, which is when we're dividing by the W component, or Opengl does. And in the way that we've set it up, think about how to communicate this. So we know that this can be just plus D lots of W, right? But then also, like, this D is meant for translation, and there isn't any translation going on in the points. So really the only realistic ones which we should be thinking about are A and C. So we know that XP is some coordination of C plus CZE. Okay, and here we've got A, but we've got plus minus right minus left over here. Now that will get times, okay, I see what's going on. So basically, Opengl does the divide where it divides by the W component of the resulting vector. So geoposition, it will divide by, yes, it divides by W. And it's common to do the mapping to copy the Z value into the W components. And right now it's 1, but it'll be done by setting this part of the matrix say to 1 or minus 1, which it depends. You can see then for the fourth component, WP would be a dot with 0, 0, 0. WP would be ZE. And then it divides by that, right? So this is what I was missing. It completely had slipped my mind. But you have these clip coordinates, which are the coordinates which I was talking about when thinking in the range of -1 to 1. So what we were looking for was not a function which took us from like XP and XE. We actually kind of already had that here. No, we did not. But ignore that. We were looking for a function which took us from clip coordinates to this. So if let's try look at what is the difference between this calculation here, which had this part, which was the mapping from -1 to 1, that needs to be combined with the perspective projection part. Well, the differences between the two, if we substitute this in, yes, I should have done this. I should have substituted it before. Okay, let's just consider this. Let's just consider this. After we have gone through and we're at the stage in clip coordinates where Opengl has divided everything by Z. So at this point, No, I was thinking about it wrong. Take a look at this equation. What two components do we have? We've got the x coordinate and the z coordinate. So we know that in our final equation we need some combination of the x coordinate and the z coordinate. But we also, comparing these two, take a look. We need I've confused myself. Oh, it sucks. I was so close to it all. Only once you found the projected coordinates. Right now, we got the x coordinate, xy coordinates. Oh. Ah. Why don't I just write... Instead of writing it like that, we'll do xc, it's xp, ze, all over near, like this. Okay, and then we take a look at our equation for f of xp. Damn, it's really bothering me. I might have to reference some material. Ah. I was so hoping to do this. One last sprint of thought and okay, I'm fine. I'm fine with my once we have the projected coordinates, I'm fine. Everything's fine. I'm just missing the mapping from the f of xe to f of xp. Okay, because I need to be thinking in terms of a vertex. When we're thinking about vertex, we already have access to ze, so it's not that ze value that I'm thinking, oh, it has to come in from a function. It doesn't actually have to come in from the function. Because what I'm really looking for, I can consider ze to be something fixed. So I'm just looking for xe to xp. Because I'm just looking for xe to xp, I know that, like I said over here, I know that it's according to this equation, xp times ze over near. Okay. That's how to get from... this is the full equation I need. This is the full equation I need. It's so simple, like, I just... if we think about... Yes. If we think about what the difference is between the projected coordinate and the clip coordinate, it's just that the projected coordinate undergoes a division by w. But I think for the sake of it, w is z. at this point. So W is Z. So then we get this equation here. Flip coordinates is equal to super frustrating. I mean, just really not. Okay, I need to try and figure out. See, this is good. Like I've got. Wait. What is this? A function that takes in the... Yeah, this is the mapping from xp to -1 to 1. Now I need the mapping from f of xe. And that's in clip coordinates. So... Wait, I'm mapping from -1 to 1. Oh, yeah, I don't really know. I haven't quite got that right. I think I might have to do some referencing to some material to remind myself how to do it. I've given it a long thought. I have failed to realize it. Man, that feels bad. I'm just looking for this person's got the projection matrix. All right, the rest of this is just going to be reading up on graphics math because I can improve on that a lot. All right, so we're going to read through this article from start to beginning. So a computer monitor is a 2D surface. 3D scene rendered by Opengl must be projected onto the computer screen as a 2D image. Geoprojection matrix is used for this projection. Transform. Yes. First transforms all vertex data from the I coordinates to clip coordinates. I might be mistaken in thinking clip coordinates are -1 to 1. Okay, it seems like I am. Clip coordinates are ranging from -W to a W. So that's my first mistake. So then these clip coordinates are... Let me just write a little note now on what I need to do by the end of this. Equivalent is transformed to the normalized device coordinates by dividing with the W. Okay, so yes, so we've got the projection matrix and we're multiplying by that vector, which we'll call VE, and then this gives us clip coordinates because the vertex shader should output in clip coordinates. Then these clip coordinates undergo the perspective divide, which is division by W. VE.W, I'd say, to produce normalized device coordinates. Just details which I mixed up. Therefore, we have to keep in mind that both clipping, which is they've put in brackets frustum culling, and the NDC transformations are integrated into the GL projection matrix. Okay, I think it's fine. I think what they're saying is that we have to take into account that because of this fixed function pipeline, we have to take a step back. So we know this is where we are. We know that division by VE.W is going to happen. So times everything by Z. Maybe. To counteract the division. Maybe. Probably not. The following sections describe how to build the projection matrix from 6 parameters: left, right, bottom, top, near, and far. Note that frustum culling or clipping is performed in the clip coordinates just before dividing by W. Yes, so the actual clipping happens before this division. So clipping occurs here. The clip coordinates XC, YC, and ZC are tested by comparing with WC. If any clip coordinate is less than minus WC or greater than WC, then the vertex will descend. Yes, so this is the boundary, which will be discarded. Here, this is a little different. We are already gone through the viewport transform, which happens after MDC. But you can see that these vertices are lying outside. So it needs to create a new geometry. And when I say it, I mean the rasterizer, that is able to account for the fact that this was outside. It will probably do this by splitting that up into 3 triangles. You see it says OpenGL will reconstruct the edges of the polygon where clipping occurs. Now, yeah, so I do think that happens in the rasterizer, or when clipping is occurring, like it's saying, which is before NDC, it will almost like run a geometry shader of some sorts. Let's see. In perspective projection, a 3D point in a truncated pyramid frustum. Okay, so sorry. In a perspective projection, 3D point in a truncated pyramid frustum in I coordinates is mapped to a cube. So yes, so any point in here will get mapped to this sort of NDC cube minus 1, 1, 1. And you can see I've written that clearly here. This diagram. And Z from minus n minus f to minus 1 to 1. So yeah, that's fine. It's minus here because in this assumption, you can see that they're assuming the camera is pointing down or sitting down, looking down the minus Z axis. Note that the I coordinates are defined in the right-handed coordinate system, but NDC uses the left-handed coordinate system. Now, I'm not sure left-handed, right-handed coordinate systems, so I do need to research what that is. So here we've got, where is this from? University of Illinois. A left-handed coordinate system. The default coordinate system is left-handed in this whatever render man. And the positive X, Y, and Z axis point right, up, and forward. So kind of like this, if you look at the my hands. This is left-handed, right? And I assume if I were to mirror it, this is what it's talking about. Let's see. Oh yeah. in Opengl, it's right-handed. The positive X and Y axis point right and up. Okay. And the negative Z axis points forward. So the only difference is the direction which the Z axis points. Now let me try and figure out which which hand motion it means. Yeah, no. No. The only thing which, yes, why is it called left-handed and right-handed? Here we go. I don't know if I'm allowed to watch YouTube videos. Let's see.
I'm going to look at how we can tell if a system is a right-handed coordinate system or a left-handed coordinate system. This is important because one of the easiest ways to mess up a vector question is to draw your coordinate axes incorrectly. If you draw them as a left-handed system, you'll end up getting confused and you'll end up getting negative and incorrect answers. So on my right here, I've drawn a right-handed coordinate system.
So this is a little different. You can see that unlike before, they're kind of swapped around. Here, for them, Y is our Z. So if Y is our Z, then it makes sense here, rather that, if I show you that this is the Z coordinate, this finger, and then forward is actually this right. But if you like rotate your hands, no, if you rotate your hands, then it defeats the point. Because then, yeah, then it defeats the point. But,
on my left is a left-handed coordinate system. These are essentially mirror images of each other.
you'll show us how to do the fingers, because I can't figure it out.
So I'm going to show you 3 ways now to test if a coordinate system is right-handed or left-handed.
Right.
For all of these ways, it's really important that you use your right hand, not your left hand. If you use your left hand, you're checking if it's a left-handed coordinate system. Okay, so the first way is known as the 3-finger method. So
it's what I've been trying to do.
Hand, your thumb is in the X direction, your second finger is in the Y direction, and your middle finger is in the Z direction. So 1, 2, 3.
This is her version.
So have a look at your diagram. See if you line your thumb up with the X, your second finger up with the Y, and then your third finger will point in the direction of the Z. So you'll see that's true for the right-hand coordinate system, but not for the left-hand system.
So you'll see that's true for the right-handed system. Okay, so if it aligns with my finger positions, then it's right-handed. If not, it's not. It's not. Right. Okay. So then, what I'm looking at on the screen, if I consider, I think, yeah, no, I actually don't know still. Okay, come on. This one is a good one, right? It's not just me and my brain.
hands both have 5 fingers but look different. Coordinate systems also...
No.
Just like your right hand and left hands both vice versa. To convert between these particular two systems is simply a matter of negating the z coordinate value.
Yeah, I know that. But that isn't all I need to know. I need to know how to use the fingers.
Is equally valid. It does not change the underlying reality of the situation. For example, intelligent rabbits might agree this is the standard 2D. Well, if you right-handed coordinate system. Say I want to build a building. I define the x-axis as going east and the y-axis as going north. Now my floor plan shows x pointing right, y pointing up. This is the standard 2D Cartesian coordinate system. If I define altitude as the z-axis with the arrow coming out of the diagram towards the viewer, this is a right-handed coordinate system. Why is this right-handed? Well, if you place your thumb along the x-axis and the index finger along the y-axis, the middle finger is the z-axis and points towards you. You'll notice if you try to do the same thing with your left hand, you can't match up all 3 axes, at least not comfortably.
Wait, what?
This is a left-handed coordinate system.
This guy's just confused me. You can't do the same thing with your left hand, but what? What is going on? Line it up X, Y, and Z. Oh, what's it? Is he? But my X is now pointing in the wrong way. Okay. Okay.
You can't match up all 3 axes, at least not comfortably.
Hang on. Okay, so then this is positive X. This would be Y. In right-handed. Yes. Right finger, right thumb goes right to go plus X. You align your thumb with the positive X, which, because it's the same in both coordinate systems, right? And then the index goes like this, but it's the aligning which is changing the position that positive Z is pointing towards. So in this first example here, you can see like it's kind of like looks a bit different. Really, it's just thing, but that first example is a right-handed coordinate system from my perspective, and this second example is a left-handed coordinate system. What if I'm wrong? What if I'm wrong? Let's just take a look at some images. Nice. Okay, so, okay, this is looking good. Yes. That's what I was doing. So left-handed lining points out this positive Z. Okay, good. Oh my god, it's on Microsoft as well. I should have pulled up a diagram sooner, but yeah. Okay, so now I know this. The I coordinate are defined in the right-handed coordinate system, but normalized device coordinates use, see, when it's saying this, it's actually saying in the legacy OpenGL version, NEC uses left-handed, which means that the Z positives pointing out. Maybe it's not saying legacy. That is, the camera at the origin is looking along the minus Z, but it is looking along the positive Z in NDC. And because geofrostum only accepts positive values of near and far distance, we need to negate them during the construction of the geo projection matrix. So this is fine. Geofrostum isn't used anymore. I don't really know what it was. It was like a... We go down to the versions. Is it around anymore? I'm not sure. I believe it's a legacy function. I can always give it a try. But isn't OpenGL like cross compatible? So So here in remarks, okay, so the minimum supported client is from 2000, which it's a long time ago. Yes. Anyways, that is what we were looking for. But I failed to get that, which is a shame. Better luck next time. Anyway, let me just see what this function does. Multiplies the current matrix by perspective projection. Yes, this must be legacy because so this one says it is. And we can actually pull up the spec. I forgot about this. And type in frustum. Edge flags, removed features, great. Okay, yeah. So this is old, but it's okay. Okay, so in OpenGL, 3D point in eye space is projected onto the near plane, or the projection plane. The following diagrams show a point in eye space is projected to a point on the near plane. So this is the same diagram which I have drawn. Interestingly, they've got like this negative stuff going on. I find it a little hard to think about why they are doing it negative. I believe they said it was because the camera is looking along the negative Z, and I think this is defined, this is legacy. It's not the case anymore that the camera has to look along the negative Z. So we kind of can just ignore the negatives here, -n, and just consider them to be positive, as long as we align our camera down the Z axis positive. Anyways, from the top of the view frustum, the x-coordinate of eye space xz is mapped to xp, which is calculated using the ratio of similar triangles. Yeah, so this is no problem. We've got similar triangles considering in 2 dimensions, the x and z coordinate here. But if you look, the z coordinate is fixed at this point. And because it's fixed, we're defining a plane, and then we're projecting this 3D point onto that plane, which we do by the simple way is taking using the fact that these 2 points, this one here and the point which we are inside the frustum, form a similar triangle, which how does it look? It looks like a 2-dimensional like if you are imagining this whole thing, it looks like just a 2-dimensional triangle. Yes, which extends along the z-axis and varies in its height. And then the other way would be a flat triangle, which varies horizontally. Okay, so then we have this mapping using the similar triangles for the projected coordinates. Importantly, we're going from eye space inside the frustum, because this is after we've done the inverse transformation for the camera. And we're mapping these eye space coordinates to the projected coordinate on the plane. This is the equation to do so. And then it says from the side view, yp is calculated in a similar way. So this is just really the same equation. Now the way I imagined it is so what was it again? It was to align your thumb with the right positive axis. Okay, so my thumb is at the right. This is the x-axis. This line is the z, right? Now this is positive x. So the triangle in this case, let's assume that this is the plane. This is where a point in the plane is. This is the fixed distance. And if it depends on which one we're thinking about. If we think about x and z, then we're thinking horizontal distance here. So a horizontal projection from this going in like this. That's if we're thinking x and z. But if we're thinking y and z, we're thinking about a vertical projection, and all of these combinations can basically take all the points defined in the frustum and map them onto the plane. Okay. It's actually better if you mentally visualize that. Note that both xp and yp depend on ze. Yes, so the projected coordinates do depend on the coordinates in I space. They are inversely proportional to ze. So as ze is larger, the further it gets away, the smaller xp or yp would get. In other words, they are both divided by minus ze. It is the very first clue to construct GL projection matrix. So yes, so they're saying the first clue to construct the projection matrix is that there is a division by ze. Let's take a look at how they do that. Okay, so it seems down there that they've set this as the first, but we'll just continue here. After the I coordinates are transformed by multiplying GL projection matrix. So if we remember the pattern that we need to remember, its I coordinates get transformed into clip coordinates, which are in the range -w to w for all three axes. And then clip coordinates get to NDC by this division by WC, which is the W in clip coordinates. After the I coordinates are transformed by multiplying GL projection matrix, the clip coordinates are still a homogeneous coordinate. Homogeneous coordinate is this extra coordinate which allows for translation to occur in the same matrix without having to do an additional vector addition. And there's also some other reasons why homogeneous coordinates are good. It finally becomes the normalized device coordinates divided by the W component of the clip coordinates. And it says see more details on Opengl transformation. So here we've got the clip coordinates. Being the product of the projection matrix with the I coordinates. And here we've got, this here is the NDC transformation. That mapping from the clip coordinates to NDC. And they've represented it as a 3D vector, but I think, honestly, I don't know if what the internals are in that respect. Therefore, we can set the W component of the clip coordinates as -ze. Yes, we can, right? Because here we see that these projected coordinates that we want so if we set that W component of the clip coordinate, what do we get? We get X clip over W clip, which is ZE, right? At that point in NDC, what are we missing? We're missing multiplication by the near plane, by this near distance. So I'm already understanding where I went wrong, which was to do with multiplication by this near distance. So normalized device coordinates being transformed. So they basically have considered the projection and found a equation for the projection coordinates from the eye space to projected onto a plane that is at a distance, a 2D plane, which only really has x, y, and a fixed z. Then they looked at the equation and they said, okay, there is a division by ZE, and we know that NDC, to get from clip coordinates, we divide by W. So, because we know that we need these projected coordinates to have a division by ZE, why don't we take care of that by setting the W component to Z, which is done by this here, which copies Z into W. So now WC is Z, trace it over here, X clip over Z so far. And now it's missing N times XE, but this is the first hint, as it said, to deriving the projection matrix. Okay. Then next we map XP and YP to XN and YN of NDC with linear relationship. So there isn't an explanation as to why it's linear, but they say it's a linear relationship. And I did play around with 1 and -1 to see that it can. It is undefined when L is equal to R, but when L is not equal to R, then it will be okay. Now, you might wonder, like, what if R is really close to L? Then you've got this super steep line, and there's evidently no y-intercept. Well, the equation is actually, there is a y-intercept. It's just that we don't see it visually in this range which we're defining. So yeah, because it is a line equation. So next we map XP and YP to XN and YN of NDC. Right, so these are N means NDC here. So after deriving, oops, I've now reconnected. Okay, so we were continuing here. So now we're mapping from the projected coordinate onto the -1 to 1 range, which I am familiar with. And we get this equation for the xn after doing all this substitution stuff. Let's take a look at my derivation. where did I go wrong? So here I've got an equation f of xp, but I haven't really, this is right. This is correct equation, except for, actually this is fine, because these are actually the same, this and this is the same. Just take this minus, put it here, and then make that positive. But I haven't said that f of xp is a function that maps xp to xn, which probably could have helped. Because now we have xn. And now it says, then we substitute xp and yp into the above equations. So let me think about this. We've got an equation for xn. Here's the equation to find xn based on an xp. And we've got an equation that takes in an xp. Hold on. So this is where I'm getting lost. I know where I'm getting lost. I'm getting lost when trying to go from the different stages. So I know that the relationship between normalized coordinates and projected coordinates if I really think about what we're trying to find the clip coordinates. Okay, and the clip coordinates are defined by this. This is a mapping from the sorry, that's so strange. Projected to normalized. Now look, it's saying that we substitute xp and xyp into the above equations. So we are starting with the equation here, and then it's substituting the equation for xp based on the I coordinates. Because we know the equation for xp. Yes, and by doing that we can map from E. We can go from E to N directly, which is what we want. So it is our responsibility to take it to NDC. Don't think just because it divides perspective projection divides by W that everything's fixed. We should be taking that into account. So this substitution for XP is done. And this is now going to take us from XN to from XE to the normalized device coordinates. This is just algebra simplifying. So let's just go run through this. So here's the substitution. Then this is placed into the denominator. And then this is, for some reason, just pulled up. No problem. And then we are just timesing by z minus, we're timesing by ze over minus ze over here, and changing this to a positive sign. This is just -1 times by -1. Times this by -1, but then negate this so that we're equal. Let's look at why it did that. It did that so that we are getting a common denominator, and we can perform an addition. So then the whole thing is divided by -ze. And what are we left with? We're left with this numerator, which is defined in terms of x I space and z I space. Here are the clip coordinates we put out. And then this negative ZE is what's coming from the division. And now if we just map this here to here, we know that x clip over w clip is xn. And when w clip is minus ZE, this is our equation to go from I space to clip space, and then this division happens later. And the same happens for y, which means that so note that we make both terms of each equation divisible by minus ZE for perspective division. And we set WC to minus ZE earlier, and the terms inside the parentheses become XC and YC of the clip coordinates. XC, YC. From these equations, we can see 2n over r minus l is this first here, and then r plus l minus r over r minus L. Let me just take a look at what I wrote earlier that I wanted to do. Remember clip right, yeah, so remember the path. And yeah, so now at this point we found the first two rows. So the main thing I was missing personally was this step between this substitution. When we are mapping to -1 to 1, we've now got an equation that takes projected coordinates to normalized coordinates. And earlier we found the equation for a projected coordinate. So we can actually substitute that equation for a projected coordinate to be able to go from I space directly to NDC space. Yes. And there is a little bit of confusion there with like this minus ZE. But with the algebraic manipulation, you can show that all of those terms are divided by ZE, which comes from that perspective projection later. And hence why this was copied in over here. So there is like many steps. This was copied in to allow for n times XE. And it's a little bit segmented. All of these steps don't happen at once. This is what you're putting out, XC from the clip from the vertex shader. Yeah. Now, the third row is a little bit different, it says. Says now we only have the third row of geoprojection matrix to solve. Yes, and now this is mapping the z coordinate. Now we know the z coordinate ranges from near to far, so we know that the so this is a mistake. So don't think that you can go from near to far -1 to 1 in a linear relationship, because you will find out it is a little different. Because if the z coordinate was just mapped linear like this, I don't know why it's different actually. Let's see why. So it says it's different because ZE in I space is always projected to -n on the linear plane. Yes, that's right. In I space, we're always projecting this coordinate onto this flat plane at a distance of near. So we're mapping that range near to far. That's very strange. But in clip space, it's -w to w, so I'm still not sure. We need a unique Z value for the clipping and depth test. We need unique Z value for the clipping and depth test. Yes. Plus, we should be able to unproject it to the inverse transform. Since we know Z does not depend on X or Y, yes, it's defined independently. We borrow the W component to find the relationship between the normalized Z and the projected Z. Therefore, we can specify the third row like this. Zn is equal to the Zc over Wc. That's why the this is not like this clear linear relationship like before. Because we aren't doing any projection of the Z, right? The Z coordinate is projected, it's kept on a near plane. But we still need to go from ZE to ZNDC, right? So if we go back down, we can see that we can't use X, we can't use Y, but we can use A, and we can use B. And we know the relationship to normalizes that this division will happen, and we know that this clip is minus ZE or ZE. And we know that A and B here, so like this, and so yeah, we can find this equation no problem. Let's take a look, because like when I say there is no projection, I do mean there's no projection of Z onto a plane. There is rather a mapping between near and far to -1 to 1. But because we've got this extra constraint that for the projection onto that plane to work, we need to divide everything by ZE, we have to take into that account when thinking about the equation for the third row in the matrix. In I space, WE is equal to 1. Therefore, this equation becomes AZE plus B, or minus ZE. No problem. To find the coefficients A and B, we use this relation that is n minus 1, and then just put them into the equation. No problem. Just put them into the equation, and you see now we get this two equations, and you can, yes, you can just substitute because we got two unknowns. We don't know A, we don't know B, and it's not a linear mapping. This is not linear. The equation on the top is linear, but because there's a division by some coordinate Z in the range n to f, which is not 0, remember, because we're not defining n anywhere near 0. Otherwise, this division will happen to make the outputs very large. So we know that we're dividing by a non-zero thing. But because of this division, it's a non-linear relationship between I space and the projected coordinate. Not the projected coordinate, the mapped coordinate between -1 and 1. So it's non-linear there. Anyway, this substitution, once you follow it through, gives you A, and then put A into any of these equations to find B. Once you found B, which is here just from doing this algebraic manipulation with A, you can find this relationship between by Z and E and Zn by substituting back here. No, not back there, but back here. Which gives you what? It gives you this. Now then, before it just shows me, we know that this division happens later on. So what we wanted to see is minus f plus n over f minus n in the third row there, and minus 2 fn over f minus n in that translation part. And we see that. And then we continue, just to continue with this part. This projection matrix is for a general frustum. If the viewing volume is symmetric, which means that R is equal to minus L. So if R is equal to minus L and T is equal to minus B, well, what do we have? We get minus L plus L equals 0, R minus L. So there you go. Get this and this, and then we can simplify here because you get 2R over 2n over 2R. Then you just get n over R, n over T, and because R is equal to L, well, this is just going to be R plus L, 0 over 2R, 0 over 2R, 0 over 2T, or 0. And then this is going to stay the same, reason being far and near being symmetric. Let's think about that. If far is equal to near, then we get 2n on the top, 0, division by 0. Now and we know that at least in this camera that we're defining this frustum, that far and near are both either greater than 0 or both either less than 0. Therefore, you don't have one, if there is no crossing between 0 in that range, and because there's no crossing between 0, there is no reason to set far equal to minus near. It doesn't really make sense in terms of like the shape. Before we move on, please take a look at the relationship between z in I space and normalized, or equation 3 once again. So let's do that. So you can see we've got this division by ze, right? This is a linear equation in ze, but it's being divided by ze. So it's going to cause a non-linear relationship. So it's a rational function, which should just means that it's not irrational. And is nonlinear between ZE and Zn, which means there's a very high precision at the near plane, very little precision at the far plane. So let's think about this. When we are close, something happens. 1 second. Yes, so when we're close, we seem to get more precision than when we are far, because the further we are, the larger as ZE increases. Why is it? Oh, right, from far to near. These values are very closely grouped together at the far plane. If that range minus n to minus f is getting larger, it's going to cause a depth precision problem, or Z fighting. A small change of ZE around the far plane does not affect on the Zn value. So let's just take a look at that. So a small change around the far plane, so a tiny bit, does not change the Zn value, and that's true. And we don't necessarily need to do this. We can actually map the output of this equation for different near and far, and then see the result. So I'm tempted to do that in Desmos, just as a little experiment, but I'm not really sure if it will help me that much because it's over here already. A small change of z around does not affect the zn value. The distance between n and f should be as short as possible to minimize the depth buffer precision problem. Right, because the narrower it is, the less that elongated range, the less values are mapped to a wider range. So if you have 0 to 1 in the range 1 to 10, and 0 to 1 in the range 1 to 20, well, 0 to 1 takes up 10% of the first, but it's only taking up 5% of the second, right? So that means that we've got half the values to specify in the same range, and so we can expect something like, maybe like their graph to be like, not as stretched out. Not the best explanation there. Anyways. So that's really just all in terms of the camera, this clipping and this frustament where I went wrong. Really, I should have just spared myself the trouble. Written this as xn. Like this. Writing it like this would help me to see that when xp is equal to xe over ze equals xp over near xe times near over ze, then this substitution for here xp, we substitute xe near to, and then you see that'll clearly show us getting from e to thing, and then once we've done that, we can extract out that z and demonstrate, okay, we've extracted out z. Well, we copied it in earlier, it's going to be divided by later. So here is our clip coordinates, and it will be something divided by ze. So that is, for all my sake, before like moving on to this infinite perspective matrix. What is this? Infinite projection matrix. Clearly there's a massive simplification here in the Z. By setting the far plane to infinity, because as f tends to infinity, this ratio tends towards 1, we can place 1 in the third, and as f tends to infinity over here, we see it tends to 2n as a ratio, because infinity minus n for any n is still infinity. Wait, let me just 2 infinity, f tends to infinity, what is this bound to? So we've got, yes, so we've basically got infinity divided by infinity, so it will tend to 2n, because as n is doesn't really have much of an account in this bottom part here when you're taking an infinity minus n. You can see that this will simplify to 1 to n, which makes this projection very simple. Very simple. But obviously with this infinite approach, You're obviously still suffering from depth precision problems. So there is no far plane at this point, just a near plane. And then here we've got orthographic. Now orthographic's interesting because that whole problem of Z is gone. Now we can just treat any Z as like still a mapping, just a -1 to 1. Still a projection onto the plane. But Z is now linear. So because Z is linear, so just like the other ones, huh? And there is no projection by Z. This is interesting. I need to look at later. Ah. Now, I will briefly implement a, hold on, my matrix multiplications aren't working, which is super bothering me. Geofrostum is removed. So we are back now with all this new knowledge. Back now to the same problems I had before. None of that stuff maybe helps me, but maybe it's good to know. Let me think about it. We're dividing by WC, but my approach was to... We've got 1 times model, and if you remember, model is 1. Is there a way to decompose a mat 4? In GLSL? Because if you can extract a vector, then size.x. Oh, this is using GLM, which I am actually avoiding, not using GLM. Matrix 4? Well, try matrix 4-4. As if I was going to do 4-3. Let's take a look at the GLSL spec. Try not be lazy. And I'm using version 3.3. So we are taking a look at probably some functions, right? Built-in functions, maybe. Oh, what the hell was that? What the... Oh, that was just me alt-tabbing. Okay. Matrices, here we go. Built-in types for these. Matrices of floating point numbers. The first number in the type is the number of columns. First number in the okay. The second is the number of rows. So here is columns, rows, and yes. Let's actually just take a look at uniform. The uniform qualifier is used to declare global variables. Read only, initialize externally, either at link time with the API. The link time initial value is either the value of the variable's initializer or 0 if no initializer. No problem. Uniform variables that are declared number something. If multiple shaders are linked, they will share a single. Yeah, I do wish I knew about that because I am not. I've still got the same problem I had yesterday, and I am really tempted to use AI to solve it. But I think the whole point of me doing this was to not use any AI and to try and find alternate ways of doing this. An alternate way. Maybe I should change. Yeah. Anyways, I think I'm happy with how I got so far. How I did today with helping to understand the projection matrix a little more. It was a good use of my time. I am just seeing someone who's doing FPS shooter from scratch. Oh, this guy is this guy is doing much more than me. He has got all sorts of C++ stuff that I do not touch. His name is Nathan Bags. Who is he? I think he is a very knowledgeable person. Let me ask him.
So I thought I had once capture keyboard. I thought I was using that, but it's not the end of the world. So okay, fine. So now we can. Oh, why is this not? Have I got a? Okay, got a hang on. I've got a logic. If not debug mode. I tried it and it didn't work. But that doesn't mean I did it right. It just means I gave it a jolly good go, and it didn't do what I wanted to. Okay, fine. So now we can move around the scene, and then we can F1 and bring this up. And then we can F1 to start moving around the scene again. Okay, that feels like a commit to me.
And this guy's got so much stuff.
Have you multiplied? Is your matrix multiplication correct? Have you stuck the scale factor in the right matrix holes? Are you using column major and where you meant to be using row major, and vice versa? There's a multitude of reasons why matrix maths goes wrong, and I've probably done most of them. I've probably hit most of those mistakes live.
Let me see.
We're full on FPSing. Okay, fine. So what did I do? I want to git all that for a start. What was that? imgui.ini. Okay, so build imgui. Add debug UI class. Integrate debug UI. Okay, cool. Nailed it. Done. Go home. No, please don't leave me. So the next thing I want to do is sack that off and build out something per entity. So actually, let's change entity, because I think entity. I think we can afford.
I just realized I am watching and I'm streaming at the same time, and yeah, I was just watching that stream on like full volume.
Name. That's too outrageous to say.
How can
It
I?
should have a name.
Just.
So then we go to main, and then that'll be unhappy. That'll be unhappy here.
Let me just turn down the desktop volume. Ah. Just waiting for his advice. Render doc. Okay. What is LazyGit? This guy said he was using LazyGit. LazyGit, a simple term. Oh, I should actually. Alright, this is LazyGit, and I've never seen it. But that's cool. It's kind of like a text-based. You can see all your branches, all your changes. Damn, cool. Yeah, I can't figure it out. Oh well. I think I'm gonna refactor the way that I'm handling the matrix math, because oh, hang on, my desktop audio needs to go back up. I'm just gonna refactor the way that I'm handling matrix, because first of all, let me just set it so that the scale is void. Or a static function where, no, not static. Matrix.scale and then some value. Like, I just don't get it. Hi from Nathan's. Yes, okay, give me a help. So try help me. So let me explain the problem to you first. It's quite simple. So I'm not using GLM just because I want it to be more challenging. So I wrote my own like little tiny matrix class, and over here you can see I've got a matrix. This is my class and my namespace. I pass it a pointer to a float array and a buffer size, and it's using this constructor over here. This is the constructor it's using, where I just construct like this in it for default value, and then I just loop over and then just initialize. This is just how I'm initializing the array, and I'm using a vector as the underlying buffer for the matrix, which maybe that's not a good idea. Maybe that's a first problem. But I am taking a reference to this returns a reference to the element in the buffer, and then I'm assigning it the value which was in that original buffer from my file over here. And then my scale function, which is what's important. So I loop over all the values. If the value is not 15 because of perspective division, where the division by the W component would just revert all the changes, then, you know, so scale every, right now it's like scaling every value which is not, which is like every value which is not the last, so every value which is not at index 15, which it seems like a problem, but it's not, because I'm using an identity matrix right now. So the fact that these are being times isn't a problem. Anyway, so the problem is, obviously it's not scaling. So if I change this to 3, for example, let me recompile. Sorry, fix this. And then I'll run it. Basically, no matter what I change this scale value to, the triangle stays the same size. Yes, and when I change the value here in this initial buffer, it does scale up, right? So I thought, okay, because I'm changing the number in the original buffer, maybe there is like some sort of like hidden referencing thing going on. So my solution is this awkward way of sort of initializing by taking a constant on that initial buffer. Yes, I will show you what happens when I'll just set a breakpoint here. Yes, all the values scale. So let me show you. If I run my debugger, because this was yesterday, I encountered this yesterday and I was like, okay, I need to try and debug this properly, right? So over here at this point, you can see I've got this reference to the function, sorry, the class, and this is my buffer. And hang on, there you go. Let me set another breakpoint like down here. Let me step over. Why do I call scale? I call scale here just after construction in main.cpp. And do it where you call scale. Yeah, sure. So you mean set a breakpoint here on the scale. Sorry, I think I've got a longish delay. Okay, cool. So I set the breakpoint there. And at this point, Matt is got just after it. Sorry, I stepped into that, and let me step over. Let me remove it. Continue. Okay, so here you go. So this is the state after all of the scaling has happened. And you can see my matrix is scaled. So I've got 6 at position 0, 3 at position 5, which is the next diagonal 10, and 15. And then I'm calling mat.getBuff for my uniform to upload to the model location, which I'm getting. And I will just show you the values of those. Maybe you know if there is an issue. Because the buffer is the right buffer when I call mat.getBuff. It is returning a pointer to this data. And so you'd expect it to be working with the scale. Which is why it's such an awkward bug I have. Because changing this buffer here does work. But changing this other buffer does not work. I can try to mutate maybe if I maybe if I have you heard of RenderDoc? No. Well, actually, RenderDoc is the graphics debugger, right? But I've never used it. Where's the source? Lets you see the values that are sent to the... Okay, cool. Let me... does it have a cmake? Okay, I will add it quick as a dependency. Do you know how to... Oh, okay, so let me just add it as cmake. Yes. Sounds cool. I didn't want to use it yet. I don't know why. Maybe just because I wanted to keep my dependencies as small as possible. But I think if it will help me learn what's going on, I should just maybe use it. v1.1 with a tag, and then make available render doc and link with render doc. Okay, right, so now how do you include it? So documentation. Let's go to the quick start maybe. So how do you include, first of all? Is it just download? It's a desktop app. Really? I've copied the source into my cmake because I realized it had a cmake lists. So is there a way to use it inside the project? Oh, that's LazyGit, which I was looking at. Okay, let me download it as a desktop anyway. Let me just check my... So with it, I can see what is being sent to my vertex shader. like the values which it holds. Can I inspect, for example, like the values being held in a mat4 or something? Because okay, so here I've got render doc source, which is good. So this is what I wanted. cmake is not needed. Just open and build the solution. Let me just undo all my changes and use it as a desktop app because I don't want to mess around with solutions. I see. Okay, so here it is. Let me install it. Just typical feature. It's kind of, so it's a graphics debugger. That's quite cool. Because it is like working with a black box when programming with, I mean, you can query the state, but I don't think you can easily, at least, find out the graphics side of. For some reason, my it is not pinging me to. There you go. Okay. Give it the exe to your pro. Really? That's really easy, huh? That's quite exciting. Okay. Let's open it up. Let's do not gather. Right. I'm just gonna pull this to the side. So I will go to File, Launch Application. Actually, Open Capture maybe. And then I give it my C++. Actually, where's my folder? Users desktop. OpenGL. And then Minecraft stream. Debug. Right, that's done that wrong. Maybe I can attach to running instance. Okay. No. How do I import from? Excellent. No. Do you know if it's open capture? Do I click that? Oh, what's this? Launch application. Okay. There you go. I was a bit blind there. Okay. No command line needed. Let me click launch. Oh, wow. Okay, this is interesting, huh? Okay, so how do I see the data now? Probably over here, huh? Vertex shader, geometry shader, compute shader. It's not. Why is it saying no resource? Main PID. So I captured a frame. Now I double clicked it. Okay. Oh wow. Okay. Okay, so it captures a frame and it captures all the data with that frame. And then you get to see the calls that it did. Is that right? Okay, so here's my matrix call. GL info matrix program 50. Wait, what's this? Location -1. I don't think the location is -1. Actually, unless I've just. Okay, no, I have just broken my shader now. Actually. You need to click F12 on your .exe window first. Okay, so yes, that captures a frame. F12 captures a... Thanks, okay. Okay. And then this is a timeline for what is happening. Whoa. Alright. F12. Pipeline. Current output is my back buffer cuff. Okay, and my... Let's see the color. Whoa. Okay. Anyway, so I now should use this to try and... Here it's saying I'm calling GL uniform matrix 4FE with a location of -1. And I thought that when I use my debugger, location was not -1. Because if I place my breakpoints here, and then if I continue past this point, location, wait, program. Model location is 0, you see. Your shader is broken because it's not next to the .exe file in the folder. Okay, thanks. I can just copy the shaders, right? I think that'll work. If I just copy the shaders. At least for the debugger. I've just ended my program, but the debugger is still working for some reason. That's quite confusing. Why is this still running if okay, I'll try again. So close capture. Close this. Do not save. No to all. Launch application. Launch. Okay, no, so my shader is still broken. Okay, so still no resource. Because the debugger is just running the .exe. Yes, I remember. I am opening the .exe. It's not in this here. You're right. Okay. So do you know why the vertex shader is not showing up here in my in this VS section? Because oh wait, is this not a vertex shader maybe? But okay, so let me capture and then I know I get access to a frame. It's still saying I'm putting up the location of -1. Ah, look, those values are showing the same as I saw. 6, 3. Yes. So I have a capture here. I'm pressing F12, right? And when I go to VS, there's still nothing. Am I doing that right? Wait, is this it? Rasterizer state. Oh my goodness. Yes, that's the correct height. That's the correct width and height. Frame buffers. My back buffer. GL frame buffer. Oops. No resource. I think I know the problem. Can I see your folder as your .exe? Yeah, sure. It's not in here. This is just I just added these two shaders, but I've got, it's in the build/debug/main. Your shader sources that you're reading must be there. Okay, let me change, you're telling me to change this here from shaders to builds debug. Debug. Okay, that should work now. Okay, so let me close out in File Explorer. Yes, yeah, I think they are in the same as your shader sources must, that you're reading must be that. Yes, no, okay. Yeah, keep this like this. Oh, I'm sorry, there's like a 20-second delay. So I think you are telling me to keep this the same. Keep the file path the same. Okay. Sorry. Yes, keep the file paths the same. I left them the same. What is this? I can see. Oh, here are the two shaders, which I'm okay, no, but I'm compiling them, but I don't have access to the pipeline state. Let me take a look at some of the documentation and how do I debug a shader? For the most part, at least some reflection information, but usually information for debugging is not included by default. The option to include this additional debug information varies by API. I am using direct. No, I'm not. I'm using OpenGL. What about OpenGL? Vertex debugging. I really want that. This is what I want. Now this is talking about Vulkan and Direct 3D, but nothing to do with if you go to File Path, you gave render doc. In File Explorer, what do you find? I find, I will show you. Let me pull it up. I've just copied. When you told me to copy, you said your shader sources that you're reading must be there, and I put it in. This is where main is. This is where the file I'm giving it the render doc to is this here, this main executable. And I placed the shaders in there because I interpreted you saying, as you said, your shader sources that you're reading must be there, which is why I think I attempted to change the path in main.cpp. So should I change the path or relaunch the exe using, yes. Okay, sure. Where do I go? No. Let me just, can I just press launch again? Yes. Then I would capture the frame. Detected OpenGL. Okay, and then I go to the pipeline state, and VS is still nothing here. I will try one thing, which is to just change this. I don't think this will do anything, like you said, but I'll just try it anyway. I don't want to save. Yeah. This is annoying. Oh, your fragment shader doesn't give the triangle. No, it doesn't. So that means that something is wrong with the fragment shader. And that has actually only just started happening. So it kind of... Let me run it here. So here, it's blue, but running it in RenderDoc makes it white, which means RenderDoc is not using the correct shaders. I don't know why. So here you can see I've got, maybe I need reference all resources. Consider all resources to be included. No. So have 2 copies of the shader sources. One next to the exe and the other keep them where they were originally. Sure. Sure thing. Oh, I see what you're saying. Because when I call RenderDoc in main from the debug part, it's using the local directory, which means it's looking for still the path shaders / thing. So I should have put that in a folder. I see what you're saying. My bad. Okay. Let me try again. Okay, still white triangle. Did I recompile? Wait, I don't need to recompile. Oh man. No, I'm getting... Maybe I need source... No. Oh, it's working now. Okay, it's working now. It just did need a recompile apparently. Okay, yes, to update. No, I don't know why, but okay, fine, whatever. I won't question it. It's working now. The shaders are showing. Pipeline state. I still can't see the information after capturing. Yes. But I can see my color buffer. I can't see anything to do with this shit. Oh, what's this? Hang on. What's this? I can see something. VTX. Okay, here we go. Let's take a look at this. So vertex input is index 0 is enabled. So that's good. That's what I want. But yes, no textures, no samplers, one uniform. I see. There actually was one uniform. Yes. Okay. Okay, come look. So a value of 6, 3, 3, and 1, which is what I wanted, right? So this is all right. Model has the right value. The first row is this. That's the second row. This is the third row. So this is correct. That's correct. Because I am keeping W as the value 1. Vertex UBO 0. Yes, this is all right. Wow. This is actually so cool, this program. Column major order, which means in memory they are aligned in columns, which is, yes, that's what I've done. So everything is working like kind of like the same that I first, maybe there is an issue with column row. I don't know, if I interpret this as column major, it's still the same because I have 6 0 0 0. Sorry, consider it as an array. No, the rows are correct. Yeah, it's cool. It is cool. No extension. What's this though? I've got I know, okay, so at least I know the shaders are working. Counterclockwise, rasterizer, discard, offset clamp, point size, line width, clip distance, all just stuff. Question is using this program cheating? Am I cheating the challenge by debugging with this? Nah, it's this fine. It's just a debug. It's just more info. Yeah, so still the problem is not solved. Hey, I mean, at least I got a new program to mess around with, right? What could be the problem? Honestly, no clear. Yeah, just debugging. Just debugging. Still my code. Yes, so it's all being set correctly. And things are being drawn and the scale is working because inside here we see the model uniform having these values, which is the same as scaling by 3 according to what I set. Unless, check this out, unless OpenGL is implicitly, without my knowing at all, dividing by Z without me copying W into Z. It might be implicitly copying Z into W and then doing perspective division with that. So I'm going to test that. And I'll test this by setting this scale to 0.3. Now, if my triangle is way bigger, there is implicit copying into that file. Sorry, not into that file. What's going on? Oh, it's because it's open. Let me try. So I've closed that. Close this. Launch. No. Okay. It does not look 3 times bigger, huh? So still no, not working. Pipeline state, vertex shader. Let's see what's going on. Oh, I need to load in the capture to look at the pipeline state to find my model. Model is still fine. Z is still fine. Let me try dynamically reduce the scale inside the array. So float scale equals 1.0f And then I'll do mat.scale, scale minus equals, yeah, sure thing. This is my vertex shader. So I am reading in a vec3 and simply setting W to 1 because I know that the pipeline divides the clip coordinates by W to go from NDC. And I am simply timesing by my model matrix. It's a really basic, very basic setup. I don't think there should be any problems. I'll just leave it there for a bit. Yeah. Let me zoom out. I'll be honest, I have never had a bug like this ever. This is one of the weirdest bug I've ever experienced, and I have no clue what's going on. I will try this new this is gonna give me an error, so I need to close. Oh, no error. Okay, I will try. So what I've just done is I've created just a dynamic scale so that we are just should be changing the scale. I should be seeing the triangle shrink if the uniform is being set correctly. If the uniform is not being set correctly, I won't see anything shrinking. So let me try and relaunch. And it's working. It is working. My scale is working. Okay. The scale is working. It's actually okay. So then you ask like, okay, what's the problem? Why is so strange. I feel good now that the logic was fine, but there's still a problem. Let me relaunch, and so I've now just made it shrink smaller. Sorry, take less time to shrink, so I just need to recompile. Because I was stuck on this for a whole hour yesterday, not wondering what's going on. I should have done that test sooner. My main test was checking. Yes, it's like got this input lag. Do you see that? Do you see like it freezes and then it goes? Oh. You know. Oh my god. Oh my god. Oh my god. Oh my god. No. You won't believe this. You won't believe. Take a look at this vertex. Take a look at this one. This is at the center point, right? So it's at the center point. So when I scale it, my triangle has been scaling the entire time that I have been applying my scale function. It's just that center point at 0, 0 gets scaled to 0, 0. So anytime I change the value, that point there in the middle stays the same, which is why there's that little lag there, because when I change this, if I change it to like 0.3, it's going to work. It's going to be much smaller. It was simply, I was using big scale values with a point at 0. Big scale values with a point at 0. That is actually, that is so funny. I can't believe that's so dumb. That is so stupid. Oh man. At least I'm glad I didn't use like ChatGPT to figure it out. And like on the bright side, I got a new program to debug with. So yeah, thanks. That was silly, man. That was so silly. On the bright side. Do you see what the problem was? Yeah, like with that center point, like that 0 in right in the middle. Because now check this out. This is what I'm saying. Like, if I modify this one vertex to just not be exactly 0, like even if it's like 0.5, then I will see scaling of the triangle. That is going to be one of the weirdest, like, subtle things I've missed. So now look, the point is so much higher now. Wow. Oh. And now it will cover the whole screen. Okay. Yes. Yes. I'm so happy that's working. All that like debugging, like I like got a debugger. I freaking just downloaded this graphics program only for like the problem to be this like logical combination of a vertex positioned at 0 with the wrong test settings. Because like if I had tested it with a scale factor less than 1, like I would have realized what's going on. But because all my scale factors I had ever tested with were trying to make the triangle bigger, it only ever looked like it was not scaling when it really was scaling. Really irritating, but I mean, I think I'd learned like I'd say, like, if I reflect on should I have used ChatGPT? No, because if you like look at where I am with yeah. RenderDoc is really cool program. Really cool program. I'm hopefully I can use it to like learn more about graphics stuff and like try to see test and all that stuff. Definitely gives you some more confidence in when you're like programming, because you know that when you, for example, like make multiple buffers, you'll be able to see it, whereas without RenderDoc or without something to visualize it, you'll never see how many buffers you have, or you know. So yeah. Anyways, I was before all this, I was making a camera with is there any other programs that you can recommend, because you seem to have some good knowledge on graphic stuff, so is there anything I'm missing? Because like what I know is I know about like this basic stuff, like yeah, exactly. And then when I knew it was good, the model is right, I was able to maybe think, okay, is there like something weird implicitly going on? No, and then it's something just clicked like in my head. It was like something clicked. I don't know why it clicked. I don't know what happened. It just clicked. I don't know what was going on. Just clicked. I think I remembered setting the vertices and like this faint memory of going, oh, I'm setting it to like 0.0f. Will this cause problems? Like yesterday, like, which I thought for like 2 seconds, and then that came into my mind, and I was like, oh. Yeah, that's so funny. So here's what I know. I know about Asimp for loading in things and doing like skeletal animation stuff. I know pretty much about everything learnopengl.com. suggests. So STB for image loading. Also, I don't know if you know, but you probably do know. NVIDIA Insight. Check performance on the GPU. Insight. Sweet. Family of developer tools for debugging. Alright, nice. Let me just go and get all these tools. It's so fun, like, to mess around with all this random stuff. Oh yeah, so yeah, I don't know if you know. I mean, you probably know because you seem like you have like way more knowledge on graphic stuff than me. But this person's website has got all these like super nice math derivations. Yeah, probably. It's for, what is it for? I don't even know what it was before downloading it. Large code bases. Okay, sure. Oh yes, and that reminds me, transition from OpenGL to Vulkan, what are your thoughts on like when you should transition, what reason should there be behind that decision? Because like most of this the graphics pipeline kind of stays the same as far as I'm aware, and it's just like just a more explicit process. But I think with a debugger, like I don't know about that one. Haven't used Vulkan, still new. Yes, me too. I don't have that much time to learn it at the moment. What I heard, you need to be really confident with OpenGL and graphics concepts. Yes. Yeah, I've also heard about that. For me, I've been doing like, I mean, it's kind of embarrassing, but I've been learning graphics like for quite a long time, like a bit over a year. But I just forget everything, so I'm a bit slow. It's definitely a long process, and yeah, just a bit slow mentally sometimes. But now I feel familiar with the pipeline, and it's all like pretty intuitive, close to intuitive to me. Close, not yet, but yeah, it's kind of pretty close. But there's so much stuff in OpenGL which I've never even touched. Like I've never touched pixel buffer object or anything like this. I'll show you the projects which I have done. Here, so these are the projects which I've done so far. I made this like Pong game. You can see it's got this like this retro-esque like shader, which was pretty cool. And it's got this like AI enemy. Yeah. I've got endless amounts of like willingness to learn. I just really struggle with those like processes. This was 9 months ago. But I did use a bit of AI here, like with the shaders, but the gameplay side was and the curvature AI as well to help. The gameplay was more like logical because I came from like sort of like I came from damn, my mind went blank. Yeah, I came from like using Python libraries. Yeah, that's a pretty cool one. And then this one is my graphics engine, which it's not very good. And I use AI to develop. Like I don't hold myself back with this. It's got some it's got a skybox grass rendering. I don't know how it's doing it. I was so lazy. It's really embarrassing. Like but yeah, that's why when I'm doing this here process, I'm against using AI just because I want to challenge myself to use my knowledge and learn. I think I'm finding that I'm learning better, like that I'm being more exposed by not using AI. It helps me to at least when I'm talking like this to engage better. But yeah, it's not really a graphics engine. It's really is all you can do is really just load in a model, and but the loading in the model was quite cool. Let me tell you about just one. I think it's an engine. This. Yeah, exactly. I think it's just about AI and learning, and AI is good. Like I use AI out of this project to direct myself, I suppose, but yeah. Are you in the UK? Which uni do you go to? You don't have to say if you don't want. Oh, I don't know. You seem like you're better than me, but there's this like logging library called SPD log. It's really nice, and it like outputs these nice little things. I guess with print, like you can kind of make it yourself. The new print in C++23, but Bristol. My girlfriend has some friends who go to Bristol. That's funny. I think I applied to go to Bristol. I go to Reading. I'm just doxing myself. What? Oh yes, I just realized that my thing says Reading. So you have friends who go to Reading. That's interesting. Do they do computer science? Also, how is your job search going? Like, which year are you in? Chemistry, I see. Yeah. This Nathan guy is really good at C++, huh? Like, how does he's using all these like advanced features. I never find the need to use anything advanced. Maybe because it's just not in my head, you know? Where I should use them. Like, first year, I see. What about in second year you might end up looking? No, it's fine. I think like it's just you might be doing a placement in the second year. Yeah, this guy knows a lot. This Nathan Bags. He knows a lot about all this stuff. What is OBJ viewer? Oh yeah, I need to write my own parser soon for these simple-ish OBJ files. Because that's how I'll be loading in the cubes when I eventually texture them. After I eventually write the code. 10 years of experience, right? Yeah, that makes sense. Eventually, this will be Minecraft, eventually. Just eventually. Let's see how long it takes to do. I don't. Yeah, it is normal for them, isn't it? It's I sometimes struggle with like remembering all these concepts and knowing when to use them. I don't really have the experience of like when should I use this, when should I use that. Like I'm referring to like maybe like silly concepts, not maybe silly, but like inline, or like he's using auto a lot, and I'd probably just write that out as the static type. Let's see what else he does. Const expr he uses a lot. I mean, that's just a saying that it can be determined at compile time. Did this guy just like, oh my goodness. Wait, what? Oh no, so he is working on a project that he had before. Okay, I see. It's not like he's like oh, he's done lots of like FPS from scratch streams so far. It might be good for me to watch some of these streams of his and maybe pick up some of the concepts he's using. He's also apparently made a game. Let me see his game. See, on Linux it seems. Tell because of his textures are loading in at like twice the size. Yeah, so this guy's got a lot of experience, clearly. Well, I wonder where he works. I usually like to find out where people work after, like, the job, no, the company. Oh yeah, he's written his own engine and all that stuff. He's got 3. Goodness. Yeah. So my like knowledge I will pass on to you is just be careful defining a vertex which is at 000, because it can make it really awkward to debug your transforms. There you go. That's one thing for you. Not that you're like, you probably wouldn't be dealing with that a lot though, huh? Usually you deal with like loads of vertexes. Funny that. I like, yeah. The reason I'm streaming is because I like the traceability of like my work and stuff. Like creating a traceable environment where I can demonstrate working. I want to do more C stuff, to be honest. I like C++, but sometimes I just don't like working with the code in like the standard library. Standard library is nice, but there are a lot of things I don't like about it. Like it's so verbose and gosh, like they made hash maps so complicated. Just all that's so awkward using it sometimes. Anyways. Let me, yeah. I'm going to just, what should I do? I didn't really get much done today. Oh yeah, for sure. I definitely also say, I'd say I like C++ way more than C. Just because, I mean, you can do more for sure. And I mean, using this standard library isn't really that big of a deal. Do you use like Vim or something? New Vim. Why is that? What is the benefit of using NeoVim over Vim? I used to use VS22. I need to look at what that is. Light theme. So I like the light to hit my eyes. Makes me feel more on like aware and stuff. So yes, I suppose I am light theme because it makes me feel like better concentrated, less relaxed, which helps me to concentrate. Should I, from my research, new Vim is, yeah, Vim is old. Vim is old. I never really. Oh, interesting. What do you use now then? Do you use VS Code as well? Oops. Oh, you like just use NeoVim as a thing. I see. Sorry, I got confused because so you're not using an IDE. So are you also using? Yeah. I just got confused because I have a Vim extension in VS Code. So I was thinking, oh, that's how it is, but I forgot. Yeah. Visual Studio is a lot heavier than VS Code. Where do you define it? I write enum so not often that that I forgot the syntax. This happens a lot, honestly. Actually, I won't look it up yet. I will just you. Do you have to? Because you are defining a type, so maybe you just sorry, should a type. Type. This enum should ideally also have access to it in my CPP file, but those actually it's fine. Doesn't matter. Not camera. I was just writing a simple shader file to read in. I used to use on Linux like Vim with multiple windows, but switching between files, personally, I found a bit slow. And I didn't really ever learn a better way to do it. Enum should be private. Yes, I've got private here. Okay, so that's my constructor. Need that outside the class. Oh, wait. Why do I need it outside the class? Enum shouldn't be private. Okay, I see. Need that outside the class. This is supposed to be just some internal thing for my shader to just simply use for its helper functions. For its private functions. I don't know if I want it outside. Should it be outside for the... Can you tell me why? Because I don't know why. Why should it be outside? Is it just better? Don't know. Yeah. Not supposed to be like used in anything apart from the class, the shader class. So I don't think I want it outside. What's my thing? It's just a... type. Just call it. What do I call it? Just type. Okay, fine. Okay. Right. Let's get started with this stuff. So start by loading it in. Oops. Okay, let's go ahead and create a string stream. Call it a buffer. Okay. Let's check if I once heard that checking like this is open flag is not a very good way of doing it, but I don't really know why. Oops. Speedy log. I think it's just like info. Just got to remember what I said when you said, really, I haven't heard that. Did they say the reason? I'm so close to remembering. Hang on. What did I say? What did I say? I don't remember. I literally don't remember what I said. What was I talking about? Enums and then... Man, I don't remember, sorry. I don't remember. Ah, yes. So is open is this, right? Okay, apparently it's good. But then I heard something else somewhere. Let me see. Ah, yes. I think it's because you can either basically a buffer stream object has got, I don't know if you know, but it's got like a bunch of bits which act as flags, and I think you can check the fail bit instead of is open. So this is a Stack Overflow, and it's saying standard if stream fail, which accesses the actual bit associated with the buffer. Actually, why don't we take a look at that? Because then I'd have to create an instance. Actually, why don't we check? I am using, I will run through a debugger. Through my debugger, set a point. Actually, first let's see over here. So after we create this buffer object, set my breakpoint there, and then once we load in, let's run to here, and then we'll take a look at the vertex file, right? So we can see that I believe it's some wait. Okay, which one is it? Is it file buffer or? Okay, no. Oh, this is gonna be a nightmare. I wish I just got lucky and came across it first try. Man. State. No, not state. Yeah, I don't know. Okay, let's not do it this way. Let's look at this instead, because I can't navigate that. um So this person is saying use is open, but then this person is saying use the bool conversion to just say if not I. I mean, why would you do that? I don't. That seems really weird. Honestly, I don't know. I'll be right back. All right. I will finish my shader class and then I will stop programming. Yeah, it seems like mixed advice. What is best to do? I have no clue. Probably just stick with is open, because unless someone explicitly tells you not to, like if they're reviewing your code. I also need to return here because I don't want to access anything. Then we read in the file buffer, take a string, which we'll call a buffer. String is equal to buffer.string. Okay, and then we're going to convert that to a const char star because that is what the GR spec is asking for. We'll just say the style string is equal to buffer dot, no, not buffer, buffer string dot c underscore style. Converts that to const char star for me. Finally, we can go. Yeah, it is very opinionated a lot of the times, isn't it? Like even very experienced C++ programmers say to me, use well, they don't say to me, like in their videos I watch, they'll say you know, like I use C++ kind of like in a C style, and because a lot of the C stuff, C++ stuff gets in the way, like, and this is like these guys on YouTube, low level game engine dev or something. I think he says like that he uses it kind of like in a C++ style. Anyway, I don't want to be doing this. This kind of defeats the point of me using the enum. Sorry. I want to be using a switch statement. So switch on the type is shader. And then we'll just be writing here. Make sure that I'm getting the right thing. Let me head over to the spec. Go to the create shader function. Cool. Okay, so we're actually returning a uint. Well, damn. Okay. Because do you know does the lifetime doesn't extend past. You can't return anything from a switch statement obviously as well. So I might have to create a small wrapper function, a small private function that uses like a temp. That's gonna give me problems. What should I do? What should I do? Oh, what am I thinking? Yes, I'm just trying to create a shader object, but then I realized GL create shader, right? What does it do? It returns a handle to the shader, right? So then I can just take the handle and then write it over to shader object. It's not like ideal because it takes 2 steps, but it's okay, and it lets me use a switch statement. I guess it's a trade-off. Fragment shader. Let's just copy this stuff. Shift and paste. Fragment shader. And then for the default case, I think you just write default. Also need to be breaking here. Default. In default, we will assign -1 to the shader object. Yeah. Got the break now. I don't think we need it at the end of default, but that's okay. Next, we'll just check if our shader object shader object, and we should default initialize this, right, to a value. Actually, does it return 0? It does. It can return 0, can't it? And because it can return 0, we will stick with -1. -1. Just break if shader objects equals -1. It means that is not an integer, so less than 0. I don't like that. I don't really like doing if shader object less than 0, but it kind of feels bad to do, but that's 1. Shader object not created. And then let's return from the function. Now we pass it, so we know that we've got a valid shader object. GL compile. Oops. Let's source the shader. We need our int, which is our shader object 1, because by the way, shader source and GL shader source, the second argument and the fourth argument are GL uint. Yes, unsigned int. It's the correct type uint. Oh, good point. That's actually a good catch. Good catch. Because like here I am doing less than 0. Yes, good point. So here's what I'll do. I'll set it to -1. This handle here. Or I could use a very big number, but I don't really want to use a very big number because that seems a thing. And then I will assign the unsigned int. And this is not really good practice, isn't it? Because what do you think I can do, huh? I guess in the default case, instead of checking, why don't I just return? Right? Because in the default case, this is only going to run when I oops, when in the default case is only going to run when it's not a valid shader type. So we can go back to doing this. Okay, yes, here we go. 0 is reserved for GL, which means it should not return 0. So I can do if because if it returns 0, this would not run. So if not shader, and then I can know that shader object not created, and I can avoid this whole awkward stuff with the default case, and I'll just break like normal, do nothing. I will do a SPD log that default case ran just for debugging later in case that ever happens. Then shader object not created and return. If I can, if I already know what does that mean again? If I recall correctly, okay. Right, return 0. Yes. So that's, I think that's right, and that's what I've done now. I've done if not shader object 1 and then return. Okay, so now we've created our shader object. We need to just attach the source. So let's go ahead and do that. Object 1 and then const string. So it wants to point it to my C style string. And then length also. Is length null? Do I put I think I put length as null pointer. If length is null, all strings in the string argument are considered null terminated. Good. Okay. Okay, now let's go ahead and compile that shader. Shader object. And this is a void returning. Okay, so we're going to want another function which checks the compile status. So void check compile status. We'll take in a unsigned int called the shader object, and that will be all. Let's go ahead and I wish I could remember how to screw that. Just skip that. What was it called again? Check compile status. Is my naming no, my naming's fine. Shader object. Okay, so we're going to now do all that querying, which no one really likes to do, because here we're going to have to do this. So we are going to query the shader with DL get shader IV. So I'll just type in shader IV and pull me to here. We can see the spec is saying the status can be queried with get shader IV, and see this section. Oh, what's this? Did you know about this? Look at this. The command boolean is shader, GL is shader, returns true if shader is the name of a shader object. I have never come across that. I did not know that was a thing. So instead of if not shader object, I can write GL is shader, shader object. Wow, that's good. That's good. I didn't know about that. That's really cool. Right, anyway, we want to be querying GL get shader IV with the shader object, the parameter name, so which will be a we need to do again. You have seen that. Okay, that was entirely new to me. Let's grab this switch statement. Come down here. switch on the type. And in the case that we're a vertex shader, do this. You forgot a not is shader. If returns true if yes, you're right. Because true, thank you. You're quite attentive. Okay, so switch type. Case vertex. Okay, so I need to put into type. My type is what was my enum called? Shader type. And what did I call it? Just type. Switch type. Case vertex shader. GeoGet thing, and then GeoVertex shader, which is the parameter name I want. And then for params, what do I put there? Oh, in params. Okay. No, I think I've done this wrong. Hang on. The enum and then a pointer. This is a pointer. What does it say anything about params? Give me some highlighting. Here it is. Oh, nope. Don't tell me I've... Damn. Do you remember what params is? Huh. I should have a p name is this. P name more. Oh. I've got it the wrong way around, don't I? Do you know about GL docs? Yes, GL docs. I do know about GL docs. I usually just don't like. Should I use GL docs? Yes, you're right. It's definitely better because they'll list it out in a nice table. But at the same time, I think I might like the process of having to go through the spec might actually help me to learn and remember the stuff a little bit better than getting to the answer in a more clear way through using GL docs. Yeah, something about using the spec which I like. Just maybe like it feels more authoritative, even though they're like the GL doc takes from the spec pretty much word for word. But yeah. But I will use it if I get stuck for like maybe longer than 5 minutes. Here we go. So p name is compile status. So I think I've got it the wrong way around, and I want to query the compile status of the object. Last thing is yeah, maybe it's good. See, this is quite strange. It's just talking on and on about p name, but not mentioning anything about a pointer to params. That is quite strange. If p name is, if there is no info logs, or if going on and on and on about thing. Okay, now I will use GL docs or docs.gl. because I cannot find what it's talking about. Put this over here. You'll get shader. What about shader IV? Okay, yeah. It seems it's got all the generic names. Params. Returns the requested object parameter. What type is it? It's a type pointed to an int. Okay. Sure. Maybe I should do all the... I don't know. I'm not going to start using it now. I wonder what that is used for, huh? What is params used for? Returns the requested object parameter. Returns in params the value of the parameter. Okay, and then how do I check it? Params is true if the last... Ah! Now it's coming back. Now it's coming back. Okay. Yes, I remember now. See, I'm also going to have to check if my thing is a program as well. So let me add to my shader type the enum program. Wait, this is just redundant stuff. This should be here. Parameter. And in the case of a thing, I don't want to get the shader. I think I want GL get program IV. These docs are definitely easier to use, I'll be honest. It is a lot more direct, the information which I'm getting. But I don't know. Same stuff, same pattern, just program IV. And instead of shader object, I should just say shader object. I mean, for a program, it's not really a object per se. Maybe just object ID would be a little bit more descriptive in general, but this is when you should use multiple cursors, but not gonna happen. Okay, I will do all this stuff later actually. Because for now, I'll finish this another day. Probably tomorrow actually. And let me just continue with this and leave a note. Check compile. Oops. Compile status. Finish soon. What do you mean what happened? Data source count const. Okay, yes. I need my C style string. And then for the constant length, I think there's no, all strings in the string argument are considered null terminated. Yes. Okay. Wait, why am I sourcing twice? I've literally just done that same. What am I doing? Anyway, now that it's compiled, it's fine. I should, because it's a shader object, I should store it as a member variable, the shader ID. So set it as a private. No, I don't think I want to finish it today, just because I wanted I'll just store these like that for now. Hold on a second. This is interesting, isn't it? So if I want to then store these, I have no way of knowing the type. So I might duplicate the logic, because, oh no, I do. What am I talking about? Oh my goodness. I just need another switch statement. Right. Let me actually just grab this whole switch statement and pull it down here. And delete that. And then delete this stuff in between. And leave that as is. Then we can go ahead and vertex ID, which is the member variable, equals shader object. And then this will be fragment ID. Okay, that should work then. And then that's updating the member variables. So I've now got a shader class. For some reason I've oh, yes, no problem. Compile shader vertex path. And I'll just call that twice. With just the next fragment path. I probably should do some verification on the paths. Actually, no, that's up to this function, not this function. Okay, that's all done. Right, let's go ahead and try out my new shiny class. So we'll include our shader. We'll go to our cmake file. And we will include our new source. Right, and let's make sure that we're linking with our source. Oh, we are, that's over here. Adding it. Okay, next is to just... We've included the shader. And here is all this manual stuff. Look at all this stuff. All of this stuff here, I can just delete. Okay, now I can just call my shader class with the nice paths to my shaders. Oops, should be fragment. Okay, and then I'll call this program object, so it's clearer, like not an ID. And lastly, I just need to, because I haven't done any program object stuff. Let's just go and grab this stuff. Copy this and paste this in here. Oops. Just quick. Oh man. Copy. Paste. Nice. It's kind of bugging me. But alright, it is bugging me a lot. We will just do void program. And then we'll do vertex ID and ID. We'll create program here. Let's implement create program. Okay, and I want to do all of this logic in here. Lastly is a program ID, which I've got. So delete this ID. Done. Delete that. Just put in now the member variables. A little bit like hidden stuff. Hey, whatever. It's fine. Okay, so we're creating the program now, and this is all member stuff. Okay, and just for the sake of it, last thing is just to get some getters. Actually, we don't even need getters. All we need is a void use program where we wait. Oh, this should be an underscore. That should also be an underscore. I don't really like how I've mixed camel case with these underscore stuff. I don't know which one's which. Don't remember. Yeah, that's good. So void use program is just something we can actually const qualify that one. Void should I use? No, I'm not really into football. I'm honestly not into much sport. I'm a bit fat, quite frankly. Yeah, it's quite funny. I should really lose weight. I've got a bike behind me, but I'm so lazy. What's wrong with me? Wait, this should be program ID. All right, that's all done. So we can remove this, replace this, sorry, with just program object.use. Isn't that nice? Watch football. I don't watch football, but there's no way this works first time, by the way. There's no way. Yeah, I was gonna say, like, how is that gonna work first time? Wow. There's clearly something. Just like one thing which it is hating. Yeah, so football. I have not really ever been a fan necessarily of watching it, but I think it can be exciting. I understand why people watch it. So class is missing a tag name. Right. We need to just look up the syntax because seems like I have done something wrong. Right, so we've got enum with a name, but that's not a class enum. It seems like, look, it's enum class, not like they're declaring a class called enum. That's so funny. That is so funny. I mixed up the two. Oh man. I wish it was faster to go back to the first error. This is... Always go back to the first. What? Oh. Is there an easier way to go back to the first one? Wait, there is. Watch this. I hold this and then hold this. Oh wait, no, it was up here, wasn't it? Somewhere here, somewhere here, somewhere here. Wait, what? Okay, there. Okay. What's this? Did you forget a comma? Semicolon? 16.7. In main. Yeah. Hey. That's the point. Just gotta like burn my eyes with it. What's this? What's going wrong? Shader followed by int. It's one of those weird things. I think I've forgotten a... Like, I know this one. I know this one. Just from what I've read, I know I've forgotten a semicolon at the end of the class declaration. Yeah. This one. Damn, that was a small, not a lot of errors there. Next, we've got users not a member in line 90. So I think I've done something wrong there. I might have declared it a private. Actually, what did I call it? Use program, didn't I? Shader use, yeah, it's use program. Program. Where's the next use? Oops. Program. Object.use program. And then there should be one more. That's it. All right, let's see this next problem. What is this? What is this? What is this? Next issue is I have set use program to be private when it should be public. Next one. Wait. Oh wait, actually that's the last one. Where's the next one? Okay, here's the next one. Program undeclared identifier 9149. 9149. Okay, yes, this should be program object dot. I need a way to get the ID to query. This should really be encapsulated by the program, but I just want to get it working, so I'll just create another function quick. This should not. This is not a good program function get program ID, because you don't want to be getting the program ID, preferably. Okay, but that will do. Lastly, I need to get program ID. Oh my goodness. So much stuff going on. Now I can't see my console. What's the next one? GL int 9178 again on 91. GL int, and it's expecting what? Cannot convert from void. I declared it as void. Goodness. That's supposed to be a uint. Actually, it's supposed to be an int. Okay, but I feel like we're closing in. Do you when you do like big changes like this, do you get this many problems? Or is it just me being like really inattentive when I'm programming? So what unknown override specify? There is no override. Oh, I haven't included. I should do it. Compile shader, identify not found in shader.cpp. Yes, because I have actually done underscores for all of these. Yes, that's good to know. Okay, nearly there. Okay, what's the next one? Shader compile shader does not take one argument. Good point. I need to tell it which shader. Vertex shader. Fragment shader. All right. Text shader. Nice. Then I'll do the exact same for fragment shader. Shader type fragment shader. All right. Are we close? The next issue is vertex underscore shader is undeclared in 20 line 20. Yes, because I think it's vertex ID, not shader. Okay, that's gonna cause a bit of a problem. Actually, no, it's fine. Wait, what am I? If I create a program with... that might cause an issue, actually. Okay. Buffer is undeclared in shader.cpp line 32.5. Right. Where's my buffer? Did I even make one? I haven't even made a buffer. Right, what's next? C underscore style is not a member of standard basic string. No, it's not. It's supposed to say C underscore str. Okay. That's a really weird one. That is a weird one. Next we've got vertex underscore shader is not a member of the global namespace. That's on line 40. Please don't tell me that. Don't. I'm doing this right, aren't I? Wait, what? GL create shader? Oh, it like also, of course it does, yeah. Makes sense actually. That's fine, no problem. Next. Okay, it's getting shorter, it's getting shorter. CPP 44 says that I'm redefining shader handle. Wait, is it shader handle? Yes. Okay, where am I redefining it? Let me see. All right, no worries, no worries, no worries, no worries. Oh. Yeah, but it shouldn't run twice because it's got a break. Hang on, shader handle. Shader handle. Once. What's going on? Okay, there we go. Those the only four? Yeah, okay, so Seems like I need to do a single declaration outside. Seems like it does not like the potential for multiple. So I suppose I'll just declare it outside as well. Wait, that defeats the point. What am I doing? I don't need to assign to shader. What? What am I doing? Shader, I can just directly assign here. That is some strange stuff. All right. Just make that, okay. Make that lined up. Okay, even shorter. GL attached source, identifier not found. CPV file 54. Identifier not found because every instance. Wait, what do you mean? Identifier not found? What do you mean? If you are declaring, you need a body. Okay, like a separate scope. Interesting. Okay. Luckily this way was easier in the end. Anyway, so this identifier not found, GL attached source, which means I haven't included this header, which I need. That is my outlook. Something to do with school, maybe? Wait, what's this? Still identifier not found in shader.cpp. 54. Wait, 54? Line 54 is over here. This is line 54. Oh, am I on the wrong error, maybe? Line 56, that's better. Okay. GL attached source. Did I get the syntax wrong or something? Attach source. Okay, I got the syntax wrong. It's called shader source. Where's... I'm going to call it once. Right, next. String stream redefinition in line 72. Don't know why that's all the way down there. Next. We've got an overloaded member function not found in shader. Am I forgetting two? Wait, what do you mean overloaded member function? This is interesting. See the declaration, that's in my header file, but it's saying, actually no, always go to the line first. 74, check compile status. Let me check that matches. Check compile status. It does not match. Shader type. Alright, let me just actually recall what that one was. So this is a, yes, just something not found, no problem. Alright, next up. Oh, we're so close to finally. I had so many errors. I cannot believe it. A bunch of C2065s, all for the same issue with this function. Parameter is an undeclared parameter and paramata. Okay, fix that. Okay, oh my god. Finally. Line 83, program is not defined. Yes, I know why. Shader type like that. Oh my god, just two more. Overload function differs only by return type. Yep, good point. Where is it? Is it in this file? Yes. It should be a GL int. One more. Everything's done. And we can run it. And it works the same. That's it. Okay. So we have Just created the shader class. Took a while. But hey, that's gonna happen. So we have currently got the matrix. We've got the program. We've set up the yeah, matrix. There's a couple more stuff that we have to do apart from like encapsulate VO for mesh, but meshes aren't really that important because you think about Minecraft, you're not really using meshes, huh? You're just drawing textured cubes everywhere and doing maybe raycasting for hits. Meshes aren't really important for that unless pickaxe and stuff like that, but a pickaxe is like a 2-dimensional plane, right? That has a transparent texture on it. So it's kind of like a pickaxe is just like a transparent texture, which is being animated going like that. I think. Right? I think that's how it works. Because OpenGL, like Minecraft is like, I assume Notch, the guy wanted to keep it simple, huh? You wouldn't really want to create some geometry in Minecraft or something like that. I'm not sure actually. Should we take a look? Minecraft pickaxe animation. That was probably a bad idea. We should just watch a... Yes. Yes, good point. Pigs and stuff. And cows and all that stuff. Those are just, those are kind of like meshes, yes. Especially like the legs walking. That will take... oh my god, look. This is like logging this infinite. Using program with ID. That was a bad... I feel like I've done that before. I feel like I have done that before. I should not be logging that. Anyway, let's commit our changes. Created shader class. That's kind of all I did. Okay, that's done. I was tempted to upload it to this whole thing to a repo and put it publicly in my description. What do you think about that? Do you think that's a good idea? Because then you'd be able to just like take a look at the code. Like eventually the project will get more advanced and people will have more interest in it. Like when I've actually got like Minecraft going on or something, people would be more interested to look at the code. Right now it's just a triangle. It's not really that interesting. Oh. Your choice. Okay, hang on. I just gotta remember what I said. My attention span is really, really short, clearly. Oh my god, I can't believe I forgot. I was so close to remembering. That was like 20 seconds. You can make it public. Oh yes, the GitHub repository. Yes, yes. Yeah, because like part of this whole thing is just to be like transparent about how I program at least, and like how I don't remember stuff, because there is a lot of like stuff on YouTube which is like really well formatted, right? It's like all pretty videos that don't really show the whole process for obvious reasons, and it can like create a distorted view that like people are bad when they're not actually bad, and you just have to work through the problems you come. Like even if you forget basic stuff, like then just I guess you just need to work through that when it happens. And hey, this might be terrible code. What do I know? But yeah, I think I'm done. So thanks for talking to me about all this stuff. It was really interesting finding out that you're from the UK and you go to Bristol. Yeah, and I will probably be here tomorrow. Probably here tomorrow. Because I'm trying to do this every day. I think I've been going for quite a while, like 4 hours. So yeah, I will see you tomorrow maybe, or maybe not. I don't know. It doesn't matter. It's all right. And yeah, bye. Bye.